physical AI. Physical AI. Physical AI. Okay, let's talk about physical AI.
You've probably heard the buzz about physical AI, but what actually is it? Let's take a moment here.
In the next decade, intelligence won't just live in the cloud. It will walk, grasp, and interact with our physical world. Physical AI is the fusion of advanced reasoning, real-time perception, and embodied robotics, turning code into action. Welcome to the era where robots stop being tools and start becoming teammates.
The next wave requires us to understand things like the laws of physics, friction, inertia, cause and effect. And so all of these type of physical reasoning things is what's called physical AI. And when you take that physical AI and then you put it into a physical object called a robot, you get robotics.
The Unitree G1 humanoid robot, particularly its EDU variants, has emerged as a highly customizable platform for researchers and developers aiming to push the boundaries of embodied AI. Designed with secondary development in mind, the G1 EDU series supports extensive modifications through official SDKs, such as Unitree SDK 2, ROS, ROS2 integration, and open source tools. Enabling users to upgrade hardware and implement advanced software for improved skills in locomotion, manipulation, and autonomous tasks. Key hardware customizations include optional upgrades to dexterous hands, like the 3-fingered Dex 3-1 with force position hybrid control for precise object handling or compatibility with third-party 5-fingered hands, as well as additional degrees of freedom in wrists and waist, expanding the robot from 23 to up to 43 DOF for more human-like dexterity and agility. On the software side, the thriving open-source community has driven significant enhancements via imitation and reinforcement learning. Unitree's own projects like Unitree Le Robot facilitate data collection and training for dexterous manipulation tasks, such as grasping and toasting bread, while community repositories enable RL-based skills like double spin kicks, velocity tracking, and complex locomotion in simulators like Isaac Lab or Mujo Co. before sim to real deployment. Solomon Technology has equipped the Unitree G1 humanoid robot with its Soul Vision AI and 3D vision systems running on NVIDIA Jetson platforms, enabling advanced semantic object understanding, remote perception, and autonomous industrial tasks like precise manipulation and navigation. Dubbed Supervision, this integration transforms the compact G1 into a powerful physical AI agent for semiconductor and manufacturing applications. The live demonstration was featured at SemiCon Japan 2025 in the exclusive AI Humanoid Stadium, where Solomon was one of only 4 invited exhibitors, alongside Kawasaki Heavy Industries, Unitree Robotics, and Boston Dynamics. South Korean robotics company Clobot participated in Robot World 2025, one of Asia's premier robot exhibitions, held from November 5th to 8th at Kintex in Goyang, showcasing advancements in service robotics as part of broader national efforts in AI and robot technology development. Clobot, a KOSDAQ-listed firm specializing in robot platforms, autonomous navigation, and multi-robot control systems, demonstrated innovative applications of robotic technology. The event highlighted various humanoid and service robots, though specific details on Clobot's showcase of an AI-enhanced Unitree G1 humanoid robot for guided tours, interactive dialogues, navigation, eco-friendly electric operations, and applications in museums or public spaces were featured in demonstrations, emphasizing user assistance and humorous engagement. Robot World 2025 marked its 20th anniversary with a record scale, featuring over 350 companies and focusing on smart life and industry transformations through robotics. On November 14, 2025, Mind One Robotics released a fully autonomous demo of its Mind-On AI brain on the $16,000 Unitree G1 humanoid. With zero teleoperation or speed-up, the compact robot naturally waters plants, cleans mattresses, organizes clutter, wipes counters, and handles everyday chores with impressive human-like fluency. The viral video signals that practical household humanoids are shifting from sci-fi to near reality in late 2025. The Unitree G1 humanoid robot has been turning heads on urban streets worldwide. From content creator Kai Cenat's viral stroll in New York, where it greeted surprised pedestrians with fluid waves, to a customized Jake the Rizbot version, flaunting pride gear and charming crowds in West Hollywood. Spotted in Austin and San Francisco for interactive demos, as well as Detroit's robot battle promotions, the affordable G1's lifelike gait and engaging antics are sparking excitement about everyday humanoid integration. Swiss startup Flexion Robotics raised $50 million on November 21, 2025, to build an Android-like autonomy OS for humanoid robots. In its first public demo, Flexion equipped a standard Unitree G1 with its software, enabling the robot to autonomously hike through rugged forest terrain in the Swiss Alps.
Speaking of competition, the G1 took the stage at the inaugural World Humanoid Robot Games in August 2025, also in China. The results? Absolutely stellar. The G1's hardware platform clinched 1 gold, 1 silver, and 1 bronze, proving its versatility and precision across multiple events. Whether it was speed, agility, or technical prowess, the G1 showed it's built to win, solidifying its place as a leader in humanoid robotics. And if that wasn't enough, brace yourself for this. The G1 took on table tennis and absolutely crushed it. In a groundbreaking demo, this robot rallied over 106 consecutive shots against both humans and other robots. With lightning-fast 0.42-second reactions, flawless forehand-backhand switches, and agile sidesteps, the G1 is a ping-pong powerhouse. Powered by the advanced hitter system, it combines predictive trajectory planning with reinforcement learning to adapt to every shot in real time. From deep returns to blazing smashes, the G1's precision is unreal. Slow-motion replays reveal the intricate movements, and performance data shows its unmatched accuracy. Even its rare missteps offer valuable insights, pushing the boundaries of what's next for humanoid robots. The Unitree G1 humanoid robot has demonstrated exceptional kung fu skills, performing precise punches and spinning kicks with notable balance, according to a recent showcase by Unitree Robotics. Equipped with 43 joints and advanced actuators, the G1 replicates human muscle movements, enabling smooth and fluid martial arts techniques. The robot's training, powered by NVIDIA's Isaac simulator and reinforcement learning, allows it to master complex motions by mimicking human actions through a digital twin. Originally designed for practical applications, the G1's kung fu capabilities highlight its advanced coordination and stability. Unitree's open-source platform further empowers developers to enhance the robot's agile performance, pushing the boundaries of humanoid robotics. The Unitree G1 robot has captured attention with its remarkable dancing skills, showcasing fluid and precise movements that closely mimic human choreography. Utilizing advanced AI and dynamic balance control, the robot performs complex routines with impressive synchronization and agility. Its ability to execute rhythmic steps, twists, and jumps highlights the sophistication of its motion planning systems. Audiences have been particularly amazed by its lifelike performance quality, which blurs the line between machine and performer. Overall, the dancing abilities of the Unitree G1 reflect significant advancements in humanoid robotics and entertainment technology. The G1 also features a force-controlled, dexterous hand that offers precision manipulation, perfect for handling delicate objects or executing intricate tasks. Whether it's assembling products or conducting research, the G1 ability to handle objects with human-like dexterity opens up a whole new world of possibilities for robotics. Truly cutting edge. Recently, Unitary Robotics made headlines with its humanoid robot G1, successfully performing the world's first standing side flip powered entirely by electric actuators. On March 19th, the company unveiled a video showcasing this remarkable achievement. After executing the side flip, the G1 robot maintained flawless balance, highlighting its outstanding stability, precise joint control, and real-time responsiveness. This comes just a year after Unity's H1 robot made history in March 2024 as the first electric-actuated humanoid to complete a standing backflip. On May 12, 2025, Play Robot Incorporated released a YouTube video showcasing their latest research on humanoid robots. The research introduces a technique called video mimic, which allows robots to learn complex movements like climbing stairs or sitting in chairs by watching real-world videos. The team developed a real-to-simulation-to-real process that uses everyday footage to analyze both human motion and the surrounding environment. This information helps design control strategies that enable robots to perform dynamic, full-body actions. The technique was tested on the Unitree G1, a humanoid robot with 29 degrees of freedom. It successfully learned to perform actions like stair climbing, sitting and standing using just one adaptive control policy that adjusts based on its surroundings and commands. The key innovation is a scalable method for teaching robots to operate in real-world environments by mimicking human behavior. This breakthrough could significantly advance the use of robots in areas like smart manufacture, assisted living, and everyday human-robot interaction. Welcome to the Humanoids 2024 Robotics Competition, held from November 22nd to 24th at the Nancy Center Conference Center in France. This high-stakes event brought together the world's most advanced humanoid and quadruped robots. Teams faced off in intense walking and local manipulation challenges, testing balance, mobility, and precision. Top names like Unitree Robotics, Wondercraft, Robot, TUM, DLR, Toro, Fourier Robotics, AI Robot, and Skywalkers all stepped into the spotlight, pushing the limits of robotic movement and control. The State Grid Hangzhou Electric Power Company has introduced the Unitree G1 humanoid robot to support complex maintenance operations at substations. This represents the first use of remote technical guidance via a humanoid robot in this type of environment. Equipped to inspect equipment and assist maintenance crews, the G1 demonstrates strong potential in tasks that require high-frequency precision and involve significant risk. By taking on repetitive duties and operating in hazardous conditions, the robot boosts both safety and efficiency, minimizing the need for human workers to face dangerous situations. The increasing demand for healthcare professionals, driven by aging populations and ongoing labor shortages, continues to place significant strain on hospitals worldwide. Humanoid robots, with their human life, dexterity, and adaptability, present a promising avenue to help alleviate these pressures by supporting clinical procedures. In a video published by the UCSD Advanced Robotics and Controls Lab on March 18, 2025, researchers showcased an exploratory study on the use of humanoid robots for direct patient care via teleoperation. The team developed a BI manual teleoperation system for the Unit 3D1 humanoid robot, integrating high-fidelity pose tracking, customized grasp configurations, and an impedance controller to ensure safe and precise manipulation of medical instruments. The system was tested across 7 diverse medical procedures, including physical examinations, emergency interventions, and fine motor tasks, such as ultrasound-guided needle insertions. Results demonstrated that humanoid robots can effectively replicate essential aspects of human medical assessments and interventions, showing particularly strong performance in ventilation and ultrasound-guided tasks. Despite the encouraging outcomes, notable limitations remain. The robot's restricted force output limits its effectiveness in strength-intensive procedures, and current sensor sensitivity affects clinical precision. Nevertheless, this research highlights the growing potential of humanoid robots in healthcare settings and lays important groundwork for future advancements in robotic integration within hospitals.
RoboStore has introduced KOID, a fully customized on-device humanoid robotic agent built on the Unitree G1 platform, featuring localized large language model technology that enables secure and autonomous operation entirely offline. Unlike cloud-dependent AI systems, KOID stores all knowledge, standard operating procedures, manuals, and workflows directly on its internal computer, making it particularly suitable for organizations managing sensitive or regulated data. The robot can be tailored for specific needs, including enhanced cameras, additional compute power, customized voice and behaviors, and workflow capabilities, with current applications in front desk services, multilingual translation, and visitor guidance in environments like hospitals, airports, and corporate settings. Westlake Robotics, in collaboration with Westlake University, has introduced GAE, or General Action Expert, described as the world's first universal action model. This advanced pre-trained AI enables real-time generation of arbitrary movements, allowing robots to mirror human actions with low latency and high precision, effectively transforming them into dynamic physical avatars. The shadow function technology empowers humanoid and quadruped robots to execute complex, adaptive tasks fluidly, marking a significant advancement in embodied AI for applications ranging from research to industrial automation. Robotics has introduced the Easy Deployment Kit, EDK, a standalone autonomy module designed for quick integration into various robotic platforms to provide advanced navigation and autonomous locomotion capabilities. Once installed, the EDK enables robots to surpass previous mobility and navigation constraints, delivering stable and reliable autonomous walking in challenging real-world settings. In a demonstration video, a humanoid robot equipped with the EDK showcases its impressive ability to run alongside humans in everyday environments. At the 2025 International Robot Exhibition, held from December 3rd to 6th at Tokyo Big Sight in Japan, Noitom Robotics showcased its cutting-edge motion capture technology integrated with a humanoid robot. On December 3rd, A live demonstration captured on video featured Noitom's high-fidelity inertial motion capture system, enabling real-time teleoperation and precise, fluid, human-like movements in the humanoid robot. A representative from Noitom demonstrated remote robot operation, illustrating how the company's perception neuron-based systems capture high-quality motion data to drive intuitive control and embodied AI training. Their technology supports scalable data acquisition for humanoid platforms, allowing robots to replicate natural, intelligent behaviors with greater adaptability and precision. This demonstration underscores Noitom's role in advancing humanoid robotics through superior motion data, contributing to more responsive and human-like performance in real-world applications.
When you think of robots in your mind, you imagine hardware. But the main thing behind not having robots around us today is the brain is missing. We are building what we call omni-bodied brain. Any robot, any task, one brain.
Skilled AI has raised an impressive $1.4 billion to develop a universal brain for robots of any shape or size, enabling them to learn directly from human videos and simulations for highly versatile applications across various industries. Let's take a closer look. On January 12, 2026, Skilled AI demonstrated a major breakthrough in robot learning with their Skilled Brain model. A humanoid robot learned practical skills, such as opening doors, watering plants, assembling boxes, and basic cooking simply by watching human demonstration videos. This was achieved with less than 1 hour of robot-specific data. The system shows strong robustness to disturbances, zero-shot generalization to completely new homes, and effective dexterity across different robot body types. These results highlight the power of in-context learning for adaptable robotics and mark a significant step toward versatile humanoid robots that require minimal on-site training. In August 2025, Skilled AI released a demonstration video showcasing its humanoid robot, powered by the company's general-purpose Skilled Brain Foundation model, successfully navigating complex outdoor environments, including city park stairs of varying heights and geometries. The footage underscores the long-standing challenge of stair climbing in robotics, a prime illustration of Moravec's paradox. Tasks that are effortless and intuitive for humans, such as ascending uneven steps, demand extraordinarily sophisticated integration of real-time perception, dynamic adaptation, and precise motor control in machines. By enabling the robot to adjust fluidly to irregular step depths, surfaces, and obstacles without pre-mapping or explicit planning, the demonstration represents a major leap forward in robust, real-world humanoid locomotion. Agile 1 is an advanced industrial humanoid robot from Agile Robots SE, featuring highly dexterous 5-fingered hands with 21 joints each, force torque and tactile sensors, and the ability to handle delicate tasks as well as payloads up to 20 kilograms. It uses intelligent cameras, LiDAR, speech recognition, proximity sensors, and fast movement up to 2 meters per second, combined with layered AI trained on real industrial data, enabling it to understand natural language, avoid obstacles, and perform tasks like pick and place or machine tending autonomously. Standing 174 centimeters tall and weighing 69 kilograms, Agile 1 is designed as a safe, trustworthy factory coworker with expressive eyes, chest display, lighting signals, and real-time feedback to make human-robot collaboration natural and intuitive. Matrix 3 is the latest next-generation humanoid robot introduced by Matrix Robotics, a company based in Shanghai. The promotional video showcases the robot's advanced features through impressive CGI animation, highlighting its highly dexterous hands with 27 degrees of freedom, tactile biometric skin, and claimed zero-shot generalization capabilities for versatile tasks. Announced in January 2026, Matrix 3 is positioned as a potential game-changer for applications in household, hospitality, and industrial sectors, though it currently remains in the conceptual and animated demonstration phase with no physical prototype footage available. At CES 2026 in Las Vegas, Realman Robotics showcased its embodied intelligence infrastructure, highlighting ultra-lightweight humanoid robotic arms, integrated joint modules, and a live cross-border teleoperation demo where trainers in Beijing remotely controlled a RealBot wheel-foldable robot on the show floor to perform tasks like item delivery and fruit handover. Realman Robotics is a Beijing-based Chinese company specializing in the development and production of ultra-lightweight humanoid robotic arms, designed to closely mimic adult human arm proportions with features like a 5-kilogram rated payload, high speed, and low power consumption for safe human-robot collaboration. Their RM series arms, weighing as little as 7.2 kilograms including the integrated controller, excel in applications ranging from industrial automation and service tasks to embodied AI research. While the company also contributes open-source datasets and joint modules to advance robotics technology, Tiangong 2.0 is China's latest humanoid robot, developed by the Beijing Humanoid Robot Innovation Center, and it's making serious waves in robotics. Unlike typical lab-bound prototypes, Tiangong 2.0 is built for real-world performance. It can run at 6 kilometers per hour across rough terrain like sand, gravel, and grass. While weighing just 43 kilograms and standing 163 centimeters tall. What sets it apart is its advanced AI brain, powered by state memory-based predictive reinforcement imitation learning, enabling it to learn and improve through observation. With 550 trillion operations per second, plus high-end sensors, 3D vision, motion sensors, and force feedback, Tiangong 2.0 can see, feel, and adapt like a human. It's designed for practical applications, factory work, logistics, home assistance, and even disaster rescue. With long battery life and real autonomy, it's not just impressive, it's useful. The Tiangong 2.0 features a dual battery hot swapping system that enables all-day operation without downtime by allowing quick replacement of batteries while the robot remains powered. Tiangong 2.0 builds on the legacy of its predecessor, Tiangong Ultra, which famously completed a half marathon. Tiangong 2.0 showcases advanced mobility, smoothly climbing irregular outdoor stairs through vision-based real-time perception and dynamic gait adjustment, becoming the first system to conquer 134 steps, up to 35 centimeters high, at Heizhi Wall Park in Beijing. Now, 2.0 raises the bar, aiming for mass production by 2025 and human-level learning capabilities. At CES 2026 in Las Vegas, Salcomp made its debut by showcasing a comprehensive humanoid robot technology matrix focused on core components, hardware manufacturing, and scenario implementation at booth number 1014. Leveraging its precision manufacturing expertise from consumer electronics, the company highlighted its capabilities in large-scale assembly and delivery, including services for over 5,000 humanoid robot units and plans for a future superfactory with 500,000 annual units. Meet LimX Dynamics, the pioneering force in embodied AI, building full-size humanoid robots that blend human-like agility with cutting-edge intelligence. From dynamic stair climbing and whole-body manipulation to fluid dancing and real-world adaptation, their OLI and CL series robots are redefining what's possible in general-purpose robotics. LimX Dynamics officially launched COSA, Cognitive OS of Agents, the world's first physical world-native agentic operating system, on January 12, 2026. This groundbreaking OS unifies high-level cognitive reasoning with seamless whole-body motion control, empowering humanoid robots like Ollie to think and act autonomously in real physical environments for the first time. The launch marks a major milestone in embodied AI, transforming LimX Dynamics Ollie Humanoid into the pioneering agent capable of advanced loco manipulation, combined with independent high-level cognition, as vividly demonstrated in the company's release showcase. In a recent YouTube video uploaded by LimX Dynamics on January 1st, 2026, their full-size humanoid robot Ollie is shown conquering Guangzhou's iconic skyline, likely the Canton Tower, in a dedicated robot climbing challenge, demonstrating unparalleled stability and elegance from ground level to the summit. The 165-centimeter-tall Ollie, equipped with 31 degrees of freedom and advanced real-time perception and motion control algorithms, navigates the extreme vertical structure with exceptional agility, precision, and intelligence, securing victory in the specialized event. This impressive feat underscores LimX Dynamics' leadership in embodied AI and humanoid robotics, building on the company's prior advancements in dynamic stair climbing and rough terrain locomotion with earlier models like CL1. Sanctuary AI's Phoenix, now produced in China via a joint venture, scales haptic intelligence in 2026. Standing 5 feet 7 inches and weighing 155 pounds, Phoenix lifts 55 pounds with 20 doof hands that sense 3 grams of force. Its carbon AI translates natural language into physical actions, allowing it to stock shelves, fold laundry, or assist in hospitals. With over 500 tasks mastered across 12 industries and a $90,000 price tag, Phoenix is already in Magna and Canadian Tire pilots. By 2026, China's manufacturing muscle will push Phoenix into thousands of retail and logistics sites, solving labor shortages with touch. Kawasaki's Kaleido redefines industrial versatility in 2026. This 1.75-meter bot switches between bipedal and quadrupedal modes, slashing energy use by 80% with variable wheeled feet. Its Fig Slam navigation achieves centimeter precision in factories, while heat-resistant joints handle welding and grinding. Powered by all-solid-state batteries for 6-hour shifts, Kaleido is in GAC pilots for Trumpchi assembly lines. Small-scale production begins in 2026, with Kawasaki targeting 1,000 units for automotive and heavy industry. Japan's answer to flexible manufacturing. Kawasaki's newly unveiled Kaleido 9 marks a major step forward in the company's long-running humanoid robotics program, debuting at IREX 2025 with a focus on practical, real-world assistance rather than showmanship. Building on nearly a decade of development, the 9th-generation platform integrates upgraded mobility, stronger manipulation, and improved sensing systems to operate reliably in human environments. Designed at human scale, Kaleido 9 is engineered for tasks ranging from industrial labor to disaster response, reflecting Japan's growing need for robots that can safely support aging workforces and hazardous operations. While challenges in power, agility, and real-world deployment remain, Kawasaki's commitment to iterative development and industry partnerships positions Kaleido 9 as a meaningful bridge between advanced research and everyday robotic usefulness. Neura's 4NE1 is Europe's safest collaborator in 2026. Standing 180 centimeters and weighing 80 kilograms, it carries 15 kilograms at 3 kilometers per hour with patent-pending touchless human detection that senses people through clothing. Force torque sensors offer 0.1 Newton sensitivity for delicate tasks like ironing or sandwich prep. Its Neuraverse platform enables real-time adaptation in multiple languages via voice and gesture. With exchangeable forearms and eco-friendly build, 4NE1 is in warehouse and home pilots. In 2026, it will set the standard for cognitive cobots that truly fit for anyone.
Neura Robotics opened the world's first large-scale physical AI training center, Neura Gym, in Metzingen, Germany, on October 14, 2025, with a second location launched in Hangzhou, China, just 2 days later. The 800-square-meter facility allows hundreds of robots, including Neura's 4NE1 humanoid, to collect real-world interaction data through everyday tasks, while the connected Neuraverse cloud combines this physical data with synthetic simulations to train transferable AI skills deployable instantly across all partner robots. Companies can book training space in Neura Gym to develop custom applications with Neura trainers or their own teams, supported by partnerships with NVIDIA and SAP, as the company scales the concept worldwide, following a €120 million funding round. Zhejiang Humanoid Robot Innovation Center unveiled the Navii i3 humanoid robot in November 2025. The robot is positioned as the third-generation model designed to revolutionize security applications, with its 1.8-meter height and robust build for patrolling and surveillance duties. Building on predecessors like the Navii Navigator 2, the i3 incorporates advanced AI for boundary-breaking perception and response, enabling it to protect the future through real-time environmental analysis and human-like interaction in dynamic settings. The robot's training demonstrations highlight its potential as the security guard of the future, featuring agile mobility, obstacle detection, and adaptive behaviors tailored for urban and industrial protection scenarios.
The Navii humanoid robot recently showcased its ability to perform everyday household tasks like cleaning and ironing with impressive precision. In a live demonstration, the robot efficiently carried out cleaning tasks, such as wiping surfaces and sweeping, using its highly dexterous hands and AI-powered vision system. It navigated obstacles and adapted to the environment in real time, highlighting its potential for everyday household chores. The robot also demonstrated ironing skills, adjusting the temperature to suit different fabrics and ensuring flawless execution. Its fine motor control allowed it to handle delicate materials with precision, showing its versatility for both home and professional use. This demonstration highlights the Navii robot's growing capabilities and marks a significant step toward practical applications in home automation and beyond. The Zhejiang Humanoid Robot Innovation Center continues to refine the platform with plans for further industrial deployment in the coming years. Figure03 masters autonomy in 2026 with in-house Helix AI, trained on 80 hours of video data. At 5 feet 6 inches, it folds clothes, loads dishwashers, and generalizes to thousands of items via language commands. Tactile sensing detects 3 grams, while wireless charging supports 5-hour shifts. BotQ factory targets 12,000 units annually at $15,000 to $20,000 leases. With BMW trials and multi-robot collaboration, Figure03 will enter homes and factories in 2026, redefining general-purpose robotics. Launched in October and named one of Time's best inventions of 2025, Figure03 nailed domestic tasks like folding clothes and loading dishwashers with minimal help. Optimized for mass production and powered by the Helix AI, it featured better sensors, safer design, and costs dropping fast, signaling big jumps toward everyday robots. On December 4, 2025, Figure AI's founder Brett Adcock shared a captivating short video on social media, showcasing the Figure03 humanoid robot in action, demonstrating its ability to accelerate, run dynamically with both feet off the ground, execute sharp turns, and decelerate smoothly. The footage, which has rapidly gone viral among tech enthusiasts, highlights the robot's remarkably human-like gait, complete with coordinated arm swings and fluid pivoting that eliminates any mechanical stiffness, clocking in at a top speed of about 2.7 miles per hour. This milestone not only positions Figure03 as a leader in agile humanoid locomotion, but also sparks discussions on its potential for real-world applications in homes and warehouses, blurring the line between machine and human movement. Agility's Digit dominates warehouses in 2026. With reverse-jointed legs, this 175-centimeter bot lifts 35 pounds and integrates with AMRS via Arc Cloud Management. RoboFab produces 10,000 units yearly, with Amazon and GXO pilots proving ROI. AI sensors navigate tight aisles, while backward knees climb stairs and reach shelves. $400 million in funding fuels expansion into retail and manufacturing. In 2026, Digit will be the bot earning its keep 24/7.
Two Mentibot V3 humanoids, from Menta Robotics, have demonstrated fully autonomous warehouse logistics. With no teleoperation, the robots locate, pick, and transport boxes from uneven stacks of varying heights, then accurately place them across multiple storage racks. The task showcases stable and dexterous manipulation, precise navigation in cluttered spaces, and reliable real-time decision-making, entirely driven by the robot's onboard AI and vision systems.
Spirit AI, a Hangzhou-based robotics startup founded in 2024, has developed the Moz humanoid robot, also known as Xiaomo or Moz 1, a general-purpose machine powered by advanced vision language action models for complex manipulation tasks. In December 2025, battery giant CATL announced the world's first large-scale deployment of Moz robots on its production lines, where they perform high-precision operations such as inserting high-voltage connectors and conducting quality inspections, with over 99% success rates. This milestone highlights the rapid progress in embodied AI, enabling the robots to adapt in real time to environmental variations and match or exceed the efficiency of skilled human workers in demanding industrial settings. Deep Robotics, a Chinese company renowned for its quadruped robots, unveiled the GR02 in October 2025 as the world's first industrial-grade humanoid robot with a full-body IP66 protection rating, enabling reliable operation in all weather conditions, including rain, dust, and extreme temperatures from -20 degrees Celsius to 55 degrees Celsius. The DR02 features a highly anthropomorphic design, standing 175 centimeters tall, with advanced capabilities such as a walking speed of up to 4 meters per second, obstacle navigation, and a 275 TOPS computing unit supported by multi-sensor perception for real-time environmental adaptation. With its modular quick-replace components for easy maintenance and focus on practical industrial applications like patrols, inspections, and logistics, the DR02 aims to overcome traditional limitations of humanoid robots in harsh, unstructured environments. Deep Robotics DR02 has recently been demonstrated performing graceful Tai Chi sequences and dynamic martial arts-inspired movements, highlighting its exceptional balance, fluidity, and joint coordination. These viral videos, released in late December 2025, showcase the robot transitioning seamlessly from slow, precise Tai Chi flows to more energetic actions, impressing viewers with its human-like agility and stability in complex motions. UB Tech's Walker S2 redefines home assistance in 2026. Upgraded with 52 degrees of freedom and dexterous hands, it pours coffee, cleans, and supports the elderly. BrainNet 2.0 fuses dual RGB vision for multimodal reasoning. Autonomous 3-minute battery swaps enable 24/7 operation. 500 to 1,000 units ship to BYD and Foxconn in 2025, with global consumer launch in 2026. Walker S2 is China's domestic darling gone worldwide. UB Tech dominated with massive contracts, including a $37 million deal for border security. Their upgraded Walker S2 shone in industrial settings, proving humanoids can handle tough, repetitive jobs 24/7. This marked one of the biggest actual deployments of humanoids in 2025, showing scalability is finally happening. Apptronik's Apollo is the industrial workhorse of 2026. At 5 feet 8 inches and 160 pounds, it lifts 55 pounds with force-controlled precision in BMW and Mercedes pilots. 8 design iterations yield 32 actuators for repetitive tasks without fatigue. Google AI enhances navigation in human spaces. With $403 million in funding and production scaling to 100-plus units yearly at under $50,000, Apollo is expanding into construction and retail. In 2026, it will prove humanoids can thrive in legacy factories. Google dropped game changers like Gemini Robotics 1.5 and Genie 3 world models. These let AI agents control robots in both physical and simulated worlds, advancing general-purpose capabilities. It was a massive boost for reasoning, planning, and adapting to unpredictable environments. Tesla's Optimus Gen 2.5 bridges factory and home in 2026. At 5 feet 8 inches and 125 pounds, it carries 45 pounds with 22 DOF hands trained via end-to-end neural nets. Grok AI enables voice interaction, while 4,680 batteries power autonomy. Tesla targets 100,000 units at $20,000 to $30,000, with prototypes shipping late 2025. From folding laundry to Mars missions, Optimus Gen 2.5 is Musk's army in motion. Tesla showcased huge leaps in dexterity, smooth running at near-human speeds, and factory testing. With limited production ramping up and plans for thousands more, viral demos of Optimus balancing, manipulating objects, and navigating pushed it closer to practical use in Tesla plants and potentially homes. In May 2025, Tesla's Optimus Gen 3 robot delivered an impressive display of advancement, smoothly performing a remarkably human-like dance routine that had been trained entirely through simulation and reinforcement learning. The video highlighted the third-generation model's standout features, including hands with 22 degrees of freedom for exceptional dexterity and strikingly natural, fluid motion, marking a major milestone in successfully transferring complex behaviors from virtual training to real-world execution. In November 2025, Elon Musk joyfully danced on stage with Tesla's Optimus humanoid robot at the company's annual shareholder meeting in Austin, Texas, celebrating the approval of his massive performance-based pay package worth up to $1 trillion.
In a groundbreaking demo on December 2, 2025, Tesla's Optimus Gen 2 humanoid robot demonstrated human-like fluidity in a video uploaded by former Tesla supply chain leader Farzad Mesbahi. Building on its 2021 debut, Optimus uses neural networks from Tesla's full self-driving tech for real-time AI control and dexterous hands with 11 degrees of freedom. Upcoming Gen 3 prototypes in Q1 2026 will feature 22 degrees for more intricate tasks. Tesla plans to deploy thousands of units in factories by late 2026 at under $20,000 each, targeting manufacturing, logistics, and elder care, with millions annually by decade's end, sparking mind-blowing discussions on X about autonomous physical AI.